In this video, we're going to go through solution stoichiometry. So when we do solution stoichiometry, we are still going to be following the same rules from stoichiometry. So we're going to be using conversion factors. We're always going to make sure that we start with our given, and we always want to make sure that our units are diagonal from each other so that they will cancel out. Okay. Now when we do solution stoichiometry, you're commonly going to be starting with grams, liters, or milliliters. Could also start with moles. Okay. But you will never, ever start with molarity. And you'll see what I mean in the first example, which is right here. So it says, how many liters of 2 molar potassium iodide are needed to produce 15 moles of lead iodide? Okay. So we never want to start with molarity. So what we're going to do is we are going to start with our moles of lead iodide. Okay, so here it is in the reaction, and we want to go to potassium iodide, which is on the other side of our reaction. Okay, so let's start with our 15 moles of lead iodide. Okay, and let's go back up to our flow chart. So we're going from moles to liters. So we're starting here. We're starting with moles of one thing. We're going to go to moles of something else. And then we're going to liters, so we're going to need one more jump here. And if you notice, that jump requires that we use the molarity equation. Okay, so I'll show you what that looks like in just a second. So let's continue writing this out. So we're going to need 2 steps. Okay, so since we're already in moles, we just need to do a mole ratio. So if you notice, there is not a coefficient here. So for every 1 mole of lead iodide, we have 2 moles of potassium iodide. Okay. Now, here is where the molarity equation comes into play. It's 2 molar potassium iodide. And let me just rewrite the equation. So molarity is moles over liters. Moles over liters. Okay. So that means if it's 2 molar, that means that you have 2 moles for every 1 liter. So I can use that as my conversion factor. So if this is 2 mole, or this is moles of potassium iodide, my 2 moles is going to go down here. So 2 moles of potassium iodide for every 1 liter of potassium iodide. Okay, so previously, the only time we were seeing something other than 1 with moles was our mole ratio. However, when we write out our molarity, we're going to also see numbers other than 1. So let's put this in our calculator. So we have 15 times 2. And then we are going to divide that by 2. Oh, look, it's 15 liters. All right, let's look at our next example. It says, how many liters of 1.5 molar NaOH are needed to produce 10 grams of copper hydroxide? All right. We never start with molarity. Never start with molarity. So we're going to start with our 10 grams of copper hydroxide. So let's see. So we have 10 grams of CuOH2. And if we go back and look at our flow chart, we're going from grams to liters. So we're starting here at grams and we're going to liters. So we'll need to convert our grams to moles using the molar mass. We'll need to do a mole ratio. And then finally, we're going to use the molarity equation to go to liters. Okay, so let's do all that. So let's start by finding the molar mass. So because we've already covered molar mass and we've done stoichiometry, just for time here, I'm going to give you the molar mass. And that is 97.56 grams. That's how many grams are in 1 mole. Okay, so now we're going to need to do a mole ratio. We're going from CuOH2 to NaOH. Okay, so it is a 2 to 1. So for every 1 mole of CuOH2, we are going to produce 2 moles of NaOH. Okay, just like the last problem, it tells us it's 1.5 molar. So that means there are 1.5 moles of NaOH for every 1 liter of NaOH. Okay, so let's put this in our calculator. So we start with the given, which is 10. This is in the denominator, so I'm going to divide. Okay, this is in the numerator, so I will multiply. And then 1.5 is in the denominator, so I'm going to divide. And there we go. So it looks like we have 2 sig figs, that's the least number. So I'm going to round this to 0.14 liters of NaOH. All right, one last problem. So it says, how many grams of barium chloride will be produced from 0.75 liters of 3.0 molar NaOH? Oh, I'm sorry. That's HCl. I'm still thinking of the other problem. All right, so we have grams, but that's grams per mole. That's molar mass. It's not the same thing. We do have a molarity, okay, so we won't use that. So our liters are going to be our given here. Okay, so this one's a little tricky because we have 3 different units going on, but just remember, grams per mole, that's a conversion factor. All right, so let's start with our 0.75 liters of HCl. And if you go back up and look at our flow chart, we're going from liters to grams. So we're starting here, and we're going to first convert to moles. Then we'll do a mole ratio, and then we'll use the molar mass to get to grams. So 3 steps here. Okay, so we have our molarity. It's 3 molar. So that means there are 3 moles for every 1 liter. Since we're in liters, our 1 liter is going to go on the bottom. And there are 3 moles. Okay, so again, we use our molarity and we rewrite it. So we're going from HCl to barium chloride, which is BaCl. Okay, so we have a 2 in front of HCl. So for every 2 moles of HCl, we have 1 mole of barium chloride. Okay, and then we'll use our molar mass to get grams. So for every 1 mole of barium chloride, our molar mass is 208.23 grams of barium chloride. Just like that. Okay, so let's plug this into our calculator. So we have 0.75. 3's in the numerator, so I'm going to multiply. 2's in the denominator, so I'm going to divide. And then 208.23 is in the numerator, so I'm going to multiply. Boom. There we go. So looks like we want to round to 2 sig figs. So this will be 230 grams of barium chloride. That is solution stoich.